Which of the following circles has the greatest number of points of intersection with the parabola x squared is equal to y plus 4? And we're given all the circles are centered at 0. They just have a radius of 1, root 2, 3, 4, and 5. Let's plot this parabola first. I'm going to cheat and say that I'm going to interchange x and y. I'm going to write this as y is equal to x squared plus 4. No, why am I doing this? Why am I doing this? Oh wait, no. Let's rearrange. Okay, y is equal to x squared minus 4. All right. Let's look at where this parabola lies, and maybe we can just work out geometrically what's going on here. So we have the point -4 here. When x is equal to 2 and -2, that's when we cross that axis. Okay, so greatest number of points of intersection with the parabola. Okay, so if the circle has radius 4, we clearly have 3 intersections. That was a terrible circle, but there you can see what I'm doing here. A circle of radius 4 will have 3 intersections. A circle with a smaller radius, can we get 4 intersections? Is that possible? The answer is certainly not 5, or it's certainly not the circle with radius 5, because that'll only intersect twice. It's almost certainly not the circle of radius 1. But I wonder if it's possible. Can a circle cross the parabola multiple times like that? Or at least can one of the circles given to us cross multiple times like that? In fact, I think the answer is yes. The answer is going to be x squared plus y squared is equal to 9. Yeah, it's actually easy, very easy to see. But the crossings are not going to be where I sort of had labeled them. So, that should be -2. Yeah, the way I was sketching things was very misleading. Let's just draw the circle with radius 3. Circle with radius 3 is going to cross like that and like that, right? Because it has to cross there where when y is equal to -3, it has to cross. Yeah, so this is 1, 2, 3, 4. I don't think you're going to get more intersections than that. So that'll be my answer. This is option C. Not sure if there's a sort of an elegant way to show that this is the most number of intersections that you would get between a circle and parabola, beyond doing a whole bunch of nasty. Maybe you could approach this algebraically, right? We have y is equal to x squared minus 4, and x squared plus y squared is equal to r squared. Well, you can substitute x squared is equal to y plus 4. So we have 4 plus y squared is equal to r squared. So you could think of this as a quadratic equation for y. There's 2 values. In general, there will be 2 values of y that satisfy this. And if there are two values of y that satisfy this, then in theory you could get two values of x. For each value of y, you get two values of x which satisfy it, or you can get it from there. So that might be like a more algebraic way of figuring it out. But then of course you'd have to test what values of r give you that number of solutions. Because clearly there's going to be, you know, some value of r, in particular when r is equal to 2, that you know, you see what I'm doing. Anyway, the answer is C. It's when the radius of the circle is equal to 3. Thanks for watching.